Hi Year 7 and welcome to Lesson 2. So as a starter, look at the following substances. Can you separate them into three different categories? Pause the video now and have a go. One way to separate the following would be into gases, liquids and solids. So look at the answers that are coming up underneath each square box and see how many you got right. Well done if you got all of them right. Our lesson outcomes today are: I can describe the properties of a substance in its three states. I can use the particle model to explain why different materials have different properties. What are the three states of matter? They are solids, liquids, and gases. How do the particles behave in each of these states? So let's look at describing particles in a solid. So an example here is that of a laptop screen, which is a solid. The particles are closely packed and they are in fixed positions. So the particles can only vibrate in fixed positions. They have a fixed volume and they cannot flow. They are held together in place by many forces of attraction, and they cannot be compressed. That means they cannot be squashed. How would you describe particles in a liquid? So you can say they are closely packed and they're not in a fixed place. So the particles can move around each other, that means they flow, and they have a fixed volume. They are still held together by forces of attraction, and they cannot be easily compressed or squashed. So if you've got a glass that is full of water, you can't put any more water into that glass without it overflowing. So that's what we mean by it cannot be compressed. Let's look at describing particles in a gas. So they have no fixed shape or volume. The particles are free to move in all directions, and there are very few forces of attraction between the particles. This means they can be compressed as there are spaces between the particles. What causes a change in state? The state of a substance depends on the temperature. So if you increase the temperature of the solid, it can cause the forces of attraction between each of the particles to break, and therefore the solid can now turn into a liquid. If we use gold as an example, it exists as a liquid as a solid at room temperature, but if you increase the temperature, it becomes a liquid, and if you increase it further, it can even form gaseous gold. That means that it will turn into a gas. If you look at the table on the right hand side, if you've got something that is a solid, you heat it up, it turns into a liquid. A liquid plus heat turns it into a gas. If you've got a gas and you reduce the temperature, it turns into a liquid. And if you've got a liquid and you reduce the temperature even further, you can turn it into a solid. Particle models explain properties. Explains why solids have a fixed shape, liquids can flow into different shapes, and why gases can be compressed. You're going to watch a demonstration that will explain these particle properties, or the three states of matters and their properties. I'm going to demonstrate solids, liquids, and gases using various objects I found at home. You guys can also do the same thing. So here I have a Rubik's Cube. I have some pens, which are solids. I have a bottle of water here, which is a liquid. I've got a balloon here, which contains air, which is a gas. The three states of matter can be demonstrated using water. Water can exist as a solid. So, hopefully you can see the ice cubes here. It can exist as a solid, as in solid ice. Then it can exist as liquid water, and it can exist as steam. Now, if you want to see steam, I'm sure you've seen steam loads of times at home. Just make sure you've got an adult helping you. Now, I've tried to use a flask here. Maybe you can see some of the steam. If not, like I said, you know what steam looks like. And in this cold weather, if you actually go outside and you breathe out, you'll be able to see your breath. That is also a gas. The state of a substance, water in this case, depends on the temperature. At room temperature, water is a liquid. If you reduce the temperature to 0 degrees, it will exist as a solid. And if you increase the temperature, like my flask here that has got, I did put boiling water in here, but it doesn't show too well. So it exists as a gas at 100 degrees C. How are particles arranged in solids, liquids, and gases? At home, you can use balloons to demonstrate this, if you've got balloons at home. And if you don't like balloons, you can use something else, like bricks. So over here is one I prepared earlier. I've got balloons stuck together. So the particles in this solid represent this is our solid. So the particles can vibrate around their positions. They can't move from place to place, but each particle can move in its position. So this is how we use the particle model to explain the properties of a solid. We can also use balloons to represent what particles look like in the liquid. So here's another one I did earlier. So as you can see, the liquid particles, they're not arranged in a regular pattern as in the solid, but they are still touching one another. Now, the particles can exchange places with one another. They can move from one place to another, and this is how particles in a liquid are able to, they cause the liquid to flow. Then we have gases. So these are represent our particles in a gas, which are far apart from each other. They're not touching at all. Let me show you how to draw particle diagrams. So in a solid, we can draw something that looks like our container. Then you draw circles. Make sure the circles are touching each other. And this is to show the regular arrangement of the particles. Okay, in a liquid, the particles still touch one another, but it's not in a regular arrangement like in solids. Okay, now I know it looks like really weird, but that's how you would draw. It doesn't have to be this pattern exactly, but the particles must be touching. Whereas in gases, the particles have to be far apart from each other and they're not touching at all. Here's an activity for you to do. You should already have this worksheet ready for you to download from EduLink. Alternatively, you may draw out the table. I would like you to find at least 4 objects at home and use the headings at the top of each column, which are the properties of solids, liquids, and gases, to determine if your object is a solid, a liquid, or a gas. Let's look at the example already on the screen, that of a wooden block. So the substance being observed is what you have chosen from your home. In this case, we've got the wooden block. Then you need to ask the question for each of the objects you've chosen. Does it have a fixed shape? That will be either yes or no. Can it be compressed? Can it be squashed? In this case, it's a wooden block, so no. Does it take the shape of a container? So if you put the wooden block into a glass, for example, would it take the shape of the glass? The answer is no. Does it or could it spread out and fill any space it is in? The answer is no. Can you pour the wooden block? No. So is it a solid, a liquid, or a gas? It is a solid. I would like you to have a go using the various objects that you have found. I would also suggest try and choose something unusual as well. For example, a sponge, and see whether you will classify that as a solid, liquid, or a gas using the headings on the top of the table. Pause the video now and have a go. Let's have a review of our learning outcomes. Can you describe the properties of a substance in its 3 states? Can you use the particle module to explain why different materials have different properties? If the answer is yes to both of these, then you have achieved the learning outcomes. If your answer is no, then I'm going to suggest that you pause the video and then go back to the start and see whether you can do these things. Think about how a liquid fills a glass or how a gas can fill a balloon. Why can a solid not flow and fill a glass or a balloon? Refer to particles in your answer. So when you're writing down your answer, you need to use the word particles. Liquids and gases can flow as the forces of attraction between them are not as strong as in a solid. So when you're giving your answer, you need to be able to give the opposite of what the last statement says. Jim and Bob were asked to explain why a gas takes up more room when heated. Bob thought the particles expanded, that they became bigger. Jim, on the other hand, thought that they moved about more. They spread out further and so took up more space. Who do you think was correct? Bob or Jim? Are the following substances or objects solids, liquids, or gases? Slime, sponge, sand, oobleck. If you're not sure, why don't you go back to the table you drew earlier on that shows the properties of solids, liquids, and gases? So you look at the headings at the top of each column and then ask those questions again. Does it have a fixed shape? Can it be compressed? And then see whether you can determine using those headings whether they are solids, liquids, or gases. If you can think about any more that do not fit into the categories of solids, liquids, and gases, or the 3 states of matter, That would be great, to write those down as well, if you can add to the list that is on the screen. We have come to the end of today's lesson. There is a fun experiment for you to try at home called the Oobleck. There are two web links on the screen, but because this is going to be a video, you would not be able to click on the links, obviously. So we would put the links on EduLink for you guys to have a go. You can choose whichever of the websites you find the easiest to use.